All right, so here's page 12. Looking at the first compound, we need four bonds after going through the math. And the only way to do that, because hydrogen only wants one bond, is to make a single bond there, and that forces us to do a triple bond between the carbon and nitrogen. Nitrogen to make it happy, we've got to have these extra pair of electrons there to do our ABE notation. We take a look at our central atom, and there's two atoms bound to it, so that gives us just AB2. There's no lone pair electrons on our carbon. This AB2 corresponds to a linear shape, and the two types of bonds, we have hydrogens to carbons, and we also have carbons to nitrogens. So you have to handle those separately. The hydrogen to carbon bond turns out to be nonpolar, but the carbon to nitrogen turns out to be polar. And if we go through the flow chart, we find out that this is a polar molecule because of the carbon is bound to two different elements. Looking at our next one, we're going to have four bonds, single bonds to the hydrogen, and a double bond to the oxygen. Carbon, if there's a carbon present, good chances are that'll be a central atom. Our ABE is going to be AB3, that corresponds to trigonal planar. Two types of bonds, hydrogen to carbon, still not polar. Carbon to oxygen is polar, our difference in electronegativity is 1. And we look at the flow chart, it's going to take us down the road to giving this a molecule that is polar because of the fact that carbon's bound to two different elements, as well as has a polar bond. The next one, we're going to put our oxygen in the middle. Halogens like chlorine and fluorine tend not to form central atoms. We're going to need two bonds, so we're going to have our oxygen bound singly to both fluorine and chlorine. To make oxygen happy, we're going to have two pairs of lone electrons. So therefore our ABE notation is going to be AB2, E2. It's going to correspond to our bent shape. And both of those types of bonds, oxygens to chlorine, so this bond here, and oxygen to fluorine, that bond here, they're both polar. And if we go down the flow chart, because of these lone pair electrons in here, our molecule is going to be polar. Going down to the next example, NH3, this is household ammonia. It's in glass cleaner and other household cleaners. We need three bonds. So our nitrogen is going to bond singly to each of those hydrogens. We're going to need a pair of electrons to make nitrogen happy. So we end up with AB3 because there's three hydrogens attached to our nitrogen, and then E because we've got a lone pair of electrons there. That shape corresponds to trigonal pyramidal. And the only type of bond we have are nitrogen to hydrogen bonds, which are polar bonds. Going down our flow chart, because of these lone pair electrons, we find that nitrogen trihydride or ammonia is a polar molecule. Looking at the next one, NO2 with a positive charge. We're going to need four bonds. We're going to have nitrogen double bound to each of the oxygens there. And because it's an ion, we're going to have to put it in brackets with the charge outside. In our ABE notation, there's no lone pairs of electrons, so we don't need E's for our central atom. It's just going to be AB2. I know these are double bonds, but it's still only bound to two elements, two atoms. And the shape for AB2 is linear. And the nitrogen to oxygen bonds are polar. But if you go down the flow chart, because this nitrogen doesn't have lone pair electrons and it's not bound to two different elements, it's nonpolar in the molecule. If we take a look at our third from the bottom, nitrogen trifluoride, we're going to need six shared electrons, or three bonds. So we have our nitrogen bound singly to three different fluorines. Going around making everything happy, we're going to need two electrons added to our nitrogen. Therefore, our ABE notation is going to be AB3 because of the three fluorines, E because of our pair of electrons up there, and then the shape is going to be trigonal pyramidal. We got a triangular shape, a pyramid shape. And our nitrogen-fluorine bonds, those are polar. And if we go down our flow chart, because of this pair of electrons, that's going to make this compound polar. And if we take a look at our next one here, this one's going to be a little tricky. We've got two central atoms. Once we find our 7 bonds that we need, put our two carbons next to each other, give each of them 3 hydrogens and connect them, and that uses up all of our 7 bonds. We are going to treat each of these carbons as a central atom. This one here, it's bound to 4 different things. This carbon, that hydrogen, that hydrogen, that hydrogen. So it's going to be AB4, no lone pairs of electrons on it. This carbon here, same deal, 4 different things. So that's going to be AB4. So around each of them, it's going to be tetrahedral, and our molecule is going to be nonpolar. I just have 12 seconds to do this last one, so I'm just going to scan over it, and then when it cuts me out, it cuts me out.